So since last time I've been continuing working on the electrical system. The harness for the Motec dash is almost finished, just some additional heat shrink and some connectors, and it's ready to power up and start configuring. Also, the harness for the transmission is almost done. Just some additional heat shrink and some more connectors, and this is ready to power up as well. So good progress on the electrical system. Also, during this week I'm gonna get some more additional sensors for the measuring tire temperature, and that's gonna be a good feature to measure the temperature of the tires, and with that data analyze the grip of the car. So that's gonna be good, and that's a good feature of the Motec that is already compatible with these sensors. So that's going to be a good addition to the car. It's going to be really fun. Also, I've been working on the aerodynamics on the car. I showed you guys some front aero in the last episode, and now I'm going to show you some more aerodynamics on the rear. And as a disclaimer, I'm not a professional on aerodynamics, and now I'm going to be using a lot of technical terms. I might mix some stuff up and say the wrong terminology, and so don't take my exact word for it. I might be wrong in what I'm saying. I will link to a couple of channels to a couple of guys that are really good. Kyle Forrester at JKF Aero on his channel Kyle Engineers. He's really good at explaining, and he's also he's a professional, pretty much. Yeah, he is a professional. And also AJ Hartman, who has a channel that where he explains very much in a good way how he builds the aero for his car and also for his customers. And I find his videos very easy to understand and informative as well. So that's a quick disclaimer before. Thank you. So before showing the design currently, I'm gonna show you some basics with this picture here of different car bodies. And my car, the Volvo 740, is pretty much equivalent to this truck here. And the red zones here are high pressure zones, where the airflow hits a surface here, and it gets a high pressure air resistance. And these blue parts here are low pressure points, and you might think that low pressure is something good in this case, and but what it does actually in this case, that can cause two important things that can happen, which are not good. That it can cause vortexes, which affects the airflow over the car here, and it can also cause something called wake, which is a pressure drag that pretty much prevents the car from, it wants to keep the car stationary. So I wouldn't say that it creates a vacuum behind the car, but it will pretty much suck the car in rearwards or prevent the car from moving forward. So if you look at compare the design of this truck here and this Mustang, the performance vehicle, you can see it has less drag with it's more streamlined shape here, and that will cause less of a wake here, and therefore will cause less pressure drag on this car. So that's some of the basics of what I'm gonna show you in the next picture here. In this sketch, I've added a rough sketch of swan neck wing that I'm going to be running on my car, that I'm going to build now during the fall and winter. And I have the larger element already. It's a Porsche Cup element. And I will be adding a smaller element that I'm going to build soon, and also these swan neck rear mounts for the wing, and also these end plates. And the idea with a swan neck mounted wing is that the airflow isn't hindered by the mounts as they can be if they are mounted on the bottom side of the element. And that is not a huge problem when you're driving forward. It's noticeable, but not that much. But it is very noticeable and can affect the downforce when you corner. So when the air comes a bit from the side. So in this design, it won't be that much of an issue anymore. So that's good. And also in this picture, I've added a small gurney flap. This is not the final design, just a quick sketch. And that will also help the airflow over the rear boot here, and also how the air moves when it leaves the car. So hopefully it will not create a vortex here that will create some sort of suction here that will cause drag. So hopefully it will continue to flow better, so it will not drop down here. And that's the idea with the gurney flap on the diffuser as well. So the flow will continue forward and not flow upwards or to the sides. That's the idea anyway. What's not in this design is the intakes for the rear radiator. And it's going to be a huge duct here in the roof, and also ducts in the rear windows. So we'll go through a channel to the rear radiator and goes out where the rear window used to be. And that will create a sort of a cushion of disturbed air that will flow beneath the wing here, and then the clean air will come here above the roof, ride on top of the cushion of the dirty air, and hit the rear wing much better, hopefully. And that's one of the ideas I got from Kyle at JKF Aero. So I hope this video was interesting, and that you like to see what the progress of my work on the electrical system is, and also what I'm working on in the computer. Aerodynamics is very complicated, and I skipped over a lot of terminology, and also kept it pretty simple. And if you want to learn more, as I said, head over to Kyle Engineers and AJ Hartman's channels, which are very good at implementing and explaining aerodynamics on race cars. Kyle has worked for Mercedes F1 team, and AJ Hartman designs aerodynamics for both his own car and also for his customers. So head over to them. And if you want to see more of my work, click like and subscribe to this post, and I hope to see you in the next video. Bye for now. Bye.